All right, this is the Module 6 review. All right, a weather forecaster predicts that the temperature will drop 5 degrees each hour for the next 7 hours if the temperature is 12 degrees Fahrenheit. Before the temperature starts falling, what is the temperature after the drop? So on this one, I do like the idea of putting together a picture for this one, like I put together here, right? So you got the start, which we know it starts the temperature before the temperature starts falling. Yeah, that's how much it starts at right there. So that's the start. At 12 degrees Fahrenheit, so that's this line right here, and then we know for each hour, so for each 1 hour there, it's going to drop 5 degrees. So that'd be down 5 degrees from where it starts, right? So you can see since we started at 12 degrees Fahrenheit there, it goes down 5 degrees. That would be 1 hour of time, and then you end up at 7 degrees. So if you keep going down 5 here, and we've shown the work here on the right, eventually, doing this 7 times over, you end up with negative 23 degrees. Now, the other way to do this is to figure out how much the change in temperature happened. And so since it went down 5 degrees every hour, but it did this for 7 hours, it's like having 7 groups of negative 5. So when you multiply these, there's only one negative, which makes the answer a negative. 7 times 5 is 35. We end up with negative 35. Now, that's just the change in temperature. Of course, since we started at 12, we would start with 12, and then we would add this negative 35. You could technically subtract it, but we would just use keep change this into adding a negative anyways. So either way you do this, you can see the negative 35 is bigger, so the answer is negative, and the signs are opposites. So 35 minus 12 is 23. Just tack on that negative. See how we get the same answer either way. So it works either way that you want to look at this problem. You should be good, just as long as you get the same answer. That's the main thing. The highest point at an oil drilling operation is the top of the 92-foot high oil drilling rig. The lowest point the drill head has reached so far is negative 151 feet. What is the difference between the highest point of the oil drilling rig and the lowest point? Okay, so it is asking about a difference here, right? Difference would indicate that we are using subtraction. That'll be important. But it's the difference between the highest point and the lowest point. Okay, so going back to what we know with subtraction, there should be an order, right? The only statements that should change the order would be subtracted from or less than, right? But this one is just a difference. So that's what we're going to do. We'll take the highest point, which says the highest point is the 92-foot high oil drilling rig, because that's the top of the drilling rig, right? So that's 92 feet right there, and that's positive. And then it says that it goes down to the lowest point, and the lowest point, at least so far, is that negative 151. So now the minus is different than the negative on this one. So we're going to subtract the negative 151, which will be crucial, because if you just do straight subtraction on this one, you're going to get it incorrect. Here's why. Is because when we use keep change on this one, we're going to keep the 92 positive. I'm going to change the operation from minus to plus, and then the 151, I'm going to change that as well into a positive 151. See how this ends up being an addition problem? And so 92 plus 151, let's see, well, what would we get on this one? 92 plus 151. What's our result here? 2 plus 1 is 3, 9 plus 5 is 14, carry the 1. 1 plus 1 is 2. 243 feet of difference between the high and low point on this. Okay. Now, just in case you were wondering, again, a diagram sometimes it's very helpful, at least for us to see visually what is going on here. So if I said this was 0 feet right there, the highest point of the drilling rig is up here at 92 feet, right? So we'll say this is 92 feet high. But then the lowest point is a negative 151 feet. Because it's below, I guess, the ocean level, wherever they're drilling. So this is why it's positive, right? Because the difference between the two, it's the distance between the two, and so you'd have to go up 151 feet and then up another 92 feet, and that's why we end up using addition here to get the 243 feet, okay? All right, so this one takes us back into just simplifying these problems. And so this is an addition problem. So we don't want to use keep change on this because it is already addition. And so in looking at this problem, I would want to know the sign of my answer. And so the 124 is positive, the 89 is negative. The 124 though is bigger, which means that the answer will be a positive. So you can put your positive sign there for now, just as long as you don't put it in your answer. Now, since the signs are opposite, we're going to take the big number, 124, and we're going to subtract the smaller number, the 89 right there. And what do we get? 4 minus 9, I have to borrow from the 2. 14 minus 9 is 5. 1 minus 8, we'll have to make that 11 minus 8, which is 3. So we already know that the sign was positive, so it just ends up being positive 35. That would be our answer. All right, so here's another addition problem. So we don't need to use keep, change, change. And again, we only use keep, change, change on addition and subtraction problems. I'm sorry, really only subtraction problems. But on this one, the two signs of the two values are both the same. They're both negatives. Negative 432 and also negative 93, which means our answer should also be negative. Now, since the signs match, we're going to take the two values, 432 and also 93, and we're going to add those two values. That's how negative the final value will be. And so in the ones place value, 2 plus 3 is 5. Tens, 3 plus 9 is 12, carry the 1. So in the hundreds, 1 and 4 makes 5. So that's a 525, but it's negative 525 because we already knew that the answer was negative from the beginning. Here's a subtraction problem. Now before, when we saw a problem like this one, we see, well, we couldn't do it because we shouldn't see negative values. Here, it's going to be negative because we're starting with something and we're subtracting something bigger than what we have to start with. So we know that the answer should be a negative. Now, if you knew that from the beginning, that's fine. I'm going to use keep, change, change on this one. So I'm going to keep the 19, 19. Okay. I'm going to change the operation into addition from minus to plus. And then that 82, which is positive, it's going to change into a negative 82 right there. Okay. So whatever I get from this should be my final answer because now we have this as an addition problem. And the 82 is negative. It's bigger than the 19, which means the answer should remain negative. So the two signs are opposites, by the way, so I'm going to take the big number, 82, and subtract the smaller number, which is 19. So what do we get? 2. I have to borrow from the 8. Make that 12 minus 9 is 3. 7 minus 1 is 6. 63, but remember the answer was negative. So there's my negative 63 as my final answer. Negative 11 plus 74. So this one's already an addition problem, but on this one I see the 74 is positive. And it's bigger than the negative 11. They're opposite signs, so that means my answer will also be positive here. And since they're opposite signs, we're going to take the big number, 74, and we're going to subtract the small number, which is 11. Whatever I get from this should be my answer. 4 minus 1 is 3. That's the ones place value. In the tens place value, 7 minus 1 is 6. Positive 63 on this one. Wasn't the last answer 63 is just negative? Well, this one's positive, so there it is. So on this one, I got a negative 468 minus negative 61. And since we're using negatives here, I shouldn't expect to see any subtraction, right? And I can change this into an addition problem with keep, change, change. So keep negative 468, just keep it negative 468. Change the operation from minus to plus, and then change this negative 61 into a positive 61. Okay? Now before, if you wanted to do this, that'd be fine. You could have just changed that into a big plus sign. It doesn't matter. You should get the same answer no matter what. All right? So I am using two values that have opposite signs. I can see that the 468 is bigger and it's negative, so my answer will be negative. Now and since the two signs are opposites, I'm going to take the big number, 468, and I'm going to subtract the smaller number, which is 61, and whatever I get from this will be my final answer. It's just going to be negative. So in the ones place value, 8 minus 1 is 7. In the tens place value, 6 minus 6 is 0, and then I'll just drop the 4. So my final answer here is not just 407, but negative 407. All right, absolute values. We've seen this before. And remember, there's a question that goes with these absolute values, and that's how far is the value from 0? I think we may have said that a different way. Let me try to think about what that was. Oh yeah, how far is, in this case, negative 157, sorry, negative 157 from 0, right? I mean, the same question, I guess, just more specifically the second time. But how far away is negative 157 from 0? It's just 157 from 0. Remember, this is not an opposite thing, though, even though these are opposites. It's a distance thing, and distances are always positive. All right, this one is different because we would need to figure out the absolute value of 61 first, okay? So again, the question changes on this one. What is the opposite of the distance 61 is from 0? I know that's not worded very well, or grammar, but it works for me. So the first thing we would want to do on this one is figure out how far away 61 is from 0, right? Which is 61. Again, remember, it's not an opposite thing. And then would say, well, what's the opposite of that? And that's the negative part. That's the opposite part. What's the opposite of positive 61? It's negative. So this ends up being a negative 61. Now, before I said that answers can't be negatives with the absolute values. That's only from the inside, okay? Because the absolute value is 61. That's the blue 61 there. But since the negative was on the outside of the absolute values, that's why we apply that then to the distance 61 is from 0. And we get negative 61. All right, now division. And so division and multiplication, it just depends on if you prefer to count or look at the two values as having the same sign or having opposite signs. After that, it's just straight division because we want to know the sign of the answer first. So on this one, we can see that the signs match. And remember, when the signs match, the answer comes out as positive, okay? Which means all we're dealing with after that is 45 divided by 9. However you look at that answer is going to be 5, and since we know it's positive, we don't need the sign. You could say positive 5 if you want, but we can just say 5 as well. All right, grab the sign numbers in the list on a number line. Okay, and this one I'm doing it by hand, although they probably will give you some of the values on a number line. You just got to click on them. So I'm going to start with 0 here on the right. Why am I not really including any positive space here? Because all 4 values are negatives there. So let's go ahead and put some values down there. 1, 2, 3, 4. These are all negatives. Negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. Maybe I could have spaced these out a little bit more. Negative 11, negative 12, negative 13, negative 14, negative 15. And that should be plenty of space. And so I'll start with negative 11. Yeah, it's just one to the left of negative 10. Now be careful, because if you're going to do this, instead of counting starting from 0, it is a common mistake for students to put negative 11 right there. Okay, it's not right there. It can't be right there, because that would be more than 10. This is negative 11, so it's less than 10. That would be 1 to the left of 10. That's negative 11 right there. So negative 6, again, it's kind of the same mistake as negative 11, but it's, you can count here. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 would be this mark. So, I mean, you can put that line right there, just circle or dot, negative 6. Negative 2, negative 2. That'd be 2 to the left from 0, so that's negative 1, negative 2. Boom, found it. Negative 2. And finally, negative 9. Whether you count or not, I mean, you can start with negative 5 and negative 10. Just go down 1. Now, down, I should have said to the right. That's to the right 1. That'd be negative 9 right there. Okay, so do be careful on these, because if you use negative 10 as your benchmark, it could go either way for the negative 9 and negative 11. You could get these switched up very easy. It's important that you don't, because we are dealing with negatives. All right, simplifying with, this is a division problem, although it's shown as a fraction. And for me, at least, and you could scale these, you could say you're going to divide them both by 10s. I just like to cross out the zeros there, which then shows it's a negative 9 divided by 1. And anything divided by 1 is itself. And, you can apply that negative, by the way. I know we talked about this during class, but if you ever see a negative out there in the front, just apply it to the numerator. So it's negative 9 divided by 1, which is just negative 9. Of course, you could have said, well, negative 9 divided by 1 like this if you'd like, but you'll still get the same answer. All right, we've got to insert less than or greater than to make the statement true, no problem. Now, it'll be interesting to note that both these values are negative, okay? So, which one is the bigger negative? The negative 73 is a bigger negative, and that's important to understand there. It's the bigger negative. There we go. Bigger negative, which means that it's less than. Okay, so that also indicates that it's less than, which would mean that negative 73 would be less than negative 37. And do be careful. Sometimes, you could get these numbers mixed up. You just kind of breeze over this. And if you looked at this on a number line, not that you have to, but if I said, well, let's put 0 here, negative 73 would be far to the left of negative 37, which indicates that negative 37 is bigger. Okay? So, again, this reads negative 73 is less than negative 37 with a little bit more, I guess, hieroglyphics than you'd probably prefer in mathematics, but there it is. So, even going back to what we talked about with money, right? Would you rather owe someone $73? This is owing because it's negative. Or would you rather owe someone $37? Well, hopefully the answer is neither, but, we'll take the 37 if I have to choose. But at least for this math problem. There you go. All right, here's another problem. We'll insert less than or greater than to make the statement true. We're comparing positive 87 and negative 476. Do be careful because sometimes, and again, it's just kind of a mental block right now, but the 87 is positive and the 47 is negative. That's crucial because positive values are always bigger. So, again, if you want to look at that as a crocodile or whatever, just eating the bigger value, it's up to you, but this reads 87 is greater than negative 476. But again, a common error is for people to see this big number right here, almost ignoring that negative right there, and then they say, well, 87 is less than negative 476. No. One's positive, one's negative. Positives are always bigger than negatives. Always, 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 okay? And again, I prefer the money example, but would you rather have $87 because it's half because you have positive, or would you rather owe $476? I'd rather have an $87 myself. So let's go ahead and simplify this one. We got negative 6 times negative 7. So this is multiplication. And remember, if you don't see the operation that's being performed, especially when you got parentheses, just know that it's multiplication. If you want to show the multiplication there, that's fine. It's up to you. But in determining whether we got to determine the sign of our answer first, and we got two negatives. 2 for me is even, so the answer is positive. Or you could say the signs match, so the answer is positive. Either way, the answer is positive. Then we're just looking at 6 times 7, which is 42. So it's positive 42. Again, we don't really need to show the positive signs, just positive 42 or 42. All right, what about negative 8 times, that's positive 12. So there's multiplication. How do we know it's multiplication? Because I can't see the operation. So it's there, just can't see it. You can show it if you want. Kind of like what we've seen with like phantom ones there. In any case, one's negative, one's positive. They're opposite signs, so the answer is a negative. For me, I like to count the negatives. This is one negative, one is odd, so the answer is negative. That works too. Then we're just dealing with 8 times 12. And you can stack and multiply that if you need to. Either way, you should get 96. So, applying the sign of the answer, there's 96, negative 96. That would be the final answer. All right, represent the quantity by sign number. Do not include units. So here we go. This one always bothers me, but it says do not include units. And whenever I see word problems, it's just instinct to label the problem, but it's telling us not to. The price of an ounce of gold dropped $235 in one day. So we know it's 235. We just got to figure out the sign of this thing. And since it did drop, this would be a negative 235. Again, my heart wants to label it. It's going to bother me that I'm not, but I'm not. I'm just not going to because it told us not to, but whatever. I'll do the same thing. We're not going to include the units. We just want to indicate the value with the signed number. positive or negative. So the temperature recorded at the peak of the mountain was 5 degrees above zero. So either way, we're dealing with 5. We just got to figure out the sign of this. And this one is above 0, which indicates that it's positive. Again, we don't really need to show that positive sign there. So I'm not going to. It's just 5. You can say positive 5 if you want to, but 5 works. All right, evaluate this one. And do be careful because you're going to see problems like this on the assignment, on the quiz, whatever, right? So we got to evaluate this. What I would want to do on this one is actually show this problem, but without the exponent. So I'm going to, it's not evaluating the exponent, just expanding it, right? So it's -3, but 4 of those, right? So I got 1, there's 2, 3, 4. And these are all being multiplied because it was an exponent. And then I would apply this negative on the outside right there, okay? Now, this is lots of multiplication between negatives, and for those of you that want to, it is okay if you wanted to show that as -1 out there in the front, which is being multiplied by -3, -3, -3, -3. So going back to kind of the way that I do this, I would say, look, how many negatives are there? Well, there's 1, 2, 3, 4, 5 negatives. 5 is odd, so I know my answer is negative, okay? Now, if you wanted to do the double negative thing, negative, negative is positive, this negative and negative is positive, 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 negative makes the answer negative. However you want to do it, it's just as important that you get the answer as a negative. That's the important part. Once you get that, then it's just multiplication straight across. I'm not going to worry about the 1, although you could say 1 times 3 times 3 times 3 times 3, right? But 1 is the identity property for multiplication, so I don't really need that. But I will do 3 times 3, which is 9. 9 times 3 is 27. And then 27 times 3. Now let's stack and multiply that. 27 times 3. 7 times 3 is 21. Carry the 2. 3 times 2 is 6, but adding 2 makes that 8. So 81. It's just my answer was a negative, right? So it ends up being a negative 81. And yeah, that'll do it. It's a very common error for students to say there's 2 negatives. Okay, well, you're seeing 2 negatives, but the 4 exponent indicates that there's 4 and then a 5th one right there. And that's why it may be better and more understandable for you to get this one correct if you were to expand the -3 to the power 4 in parentheses. So this one's similar. It's just that it's -7 in parentheses. There's no negative on the outside there. So I need 3 of these, right? There's 1, 2, I need another 1. 3 -7s, all being multiplied. And so again, for me, I would count the negatives. Since this is an exponent, it's all multiplication in here, so it's -7 times itself 3 times. Okay. Now again, for me, I like to count the negatives. How many negatives are there? 1, 2, 3 negatives. 3 is odd, which makes the answer a negative. Now I get to focus on just the multiplication with 7 times 7 times 7. And I know 7 times 7 is 49, but I'll have to stack and multiply for the final multiplication here, which is 49 times 7. So let's go ahead and stack and multiply that here in the bottom left. 49 times 7. That's a 7. 9 times 7 is 63. Carry the 6. 7 times 4 is 28, but adding 6, 28, 29, 30, 31, 32, 33, 34. So that's a 343 in the end. And that's just from the multiplication there. But our answer is negative, right? So it ends up being a negative 343 in the end. That is all.